All right, welcome back, everybody. Today we're going to be talking about standard GQ4, which is, again, it's just graphing quadratics. So this is kind of a good day for us to sit there and review a little bit as we kind of start to wrap all of these ideas together, because I know there's a lot of ideas floating around. Now, today I'm not really planning on introducing too many new ideas to you. Instead, I just really plan on trying to review and recompartmentalize everything that's inside your brain right now. So looking at this first one, right, I want you guys to know something right off the bat. There's a couple of boxes on your piece of paper here that just say skinny or fat or vertical shift. We're actually going to save those two ideas for tomorrow, and we'll incorporate those. So what I've done ahead of time is I've just went through and basically crossed out that box on each of these, and you are free to do the same. Anyone where it says vertical shift or skinny/fat. We'll talk more about what that is tomorrow and how that pertains to us, but for right now, it's not too bad. Now, looking at this one, what we're being asked to do here is to identify each of these parabola features. So a couple of different things. So obviously we have our parabola located right here, and we are being asked to figure out concavity, the line of symmetry, the vertex, and the y-intercept. Now, the order in which you go through and find these can be whichever one you prefer, but one of the things I always recommend doing is looking at your original function over here and making sure it has all of the parts to begin. And this is what I mean by that. We're missing the a value right here, so this is ax squared plus bx plus c. Having those parts there right away is very important because they are what allow us to go through and find these other pieces. Now let's just start right with concavity. So if we want to identify the concavity of our graph, that's easiest done by looking at our a value. So looking at our a value, we can see that our a value, so a is positive. And whenever this is a positive value, what that means for our concavity is that we are going to be concave up. So we can come over here and put up because of the fact that a is positive. Now, if a would have been a negative number, then we would have said concave down. The next part, I think, is almost just as easy, is to find our y-intercept. So to locate our y-intercept, remember that's always this, our c value. So our c value is the y-intercept. So looking at this graph right here, we see our c value as a positive 1. Now, when we sit there and we write our y-intercept, we typically will write it two different ways. And you want to be familiar with doing it both ways because on your test, you could be asked or you could see it multiple different ways. So we can either say that our y-intercept is 1, or in the case that we are looking for a point, if the y-intercept is 1, then that corresponds to the point 0, 1. It's just putting a 0 in that x spot. Now, to find the line of symmetry and the vertex, those two pieces kind of go hand in hand together. Now, easiest way to do these two pieces, you need to start with our formula, negative b over 2a. That's kind of the formula that starts to unlock this whole thing. So let's use that formula up here. Negative b over 2a. So in our problem, our b value is 4 and our a value is 1. So we're going to say negative 4 over 2 times 1. And when we simplify this, we get negative 4 over 2, which is negative 2. Now, that negative 2 is a very important value. By doing this, what this is this is the x coordinate. It's the x value of our vertex. And as we know with parabolas, the vertex is one of those key features of it. So the x coordinate of our vertex is negative 2. Now, in order to go through and to find the y coordinate of the vertex, what we want to do is we want to take that x coordinate that we just found and we need to plug it back in. So we're going to take negative 2 and we're going to plug it into our original function. Right, so now we want to plug back in. And whatever value comes out, whatever number, that's going to be the y coordinate. So coming over here, I know I'm running out of space. I'm sure you guys are too. We have 1 times negative 2 squared plus 4 times negative 2 plus 1. And like I said, this is something you can absolutely put on your calculator. You just want to be really careful with those parentheses when you do it. So we're going to have 1 parenthesis, negative 2 to the second power. That's not it, to the second power. Then we're going to say plus 4 times a negative 2 plus 1. And when you hit enter, we get a -3 out. Now that -3 is the y coordinate of our vertex, so we can put that in over there. Now, like I said before, the line of symmetry and the vertex go hand in hand together, and I absolutely mean that. So coming over here, whenever you want to find your line of symmetry, I normally do this after the vertex, but the line of symmetry is just x equals whatever this number is. So in this situation, x equals -2, and that is your line of symmetry. Now, again, all of these problems are going to look a little bit different. They're all going to have their own little twist and turn. I think number 3 is one of the harder ones to look at because of all the stuff it is missing. So if you look at this one, we can see right here that the value in front of this would have been an a, right? This is our a value right here. But we're missing our b and our c values, which is what makes this more difficult. Now, since we don't have any x's, we can say plus 0x to fill that spot and to give us a b value to work with. And then since we don't see a c, we can also say plus 0. So you want to add in those extra missing pieces if you see them. So up here, for example, on number 2, which is one of your problems, I'm missing that b value. So the first thing I want to do is to come over here and fill that in, right? Once you fill that in, then you're like business as usual. You can continue on with what you know. So looking over here to problem number 3, again, for concavity, we look at this first value. That's a +1. Again, since that is positive, right? So since positive, that means that we are going to be concave up. If that's negative, we will be concave down. Our y-intercept will always be dependent upon this value over here. So since that is 0, we can say that our y-intercept is 0, or as we know, we should write that as a point sometimes. So remember, when I find this value, that is the y value of the point, and then for the x value, we just always make it 0. So 0, 0 would be that point. Last but not least, we're looking for our line of symmetry and our vertex. Again, we will use our -b/2a formula. So in this situation, we'll have a -0, because that is our b value, over 2 times 1. -0 over 2. Punch that in on your calculator if you're not sure, but it gives you 0. So the x coordinate of our vertex is 0. Now, once you know what the x coordinate is, then what you want to do is go back and plug this in anywhere we see an x. This one's almost like hard because it's easy, right? There's not a lot to work with here since we have those 2 zeros for b and c. So we're going to have 1 times 0 squared plus 0 times 0 plus 0. So looking at this thing, obviously what we know here is that 0 squared is going to give us 0. 1 times 0 is going to give us 0. 0 times 0 is 0, 0, and these are all being added. 0 plus 0 plus 0, of course, gives us 0. So the y coordinate of our vertex will be 0 here as well. But that's the process. Plug it in, evaluate it. Now, again, your calculator can help you do that work if you need it. For our line of symmetry, remember this is really that easy one to get. You just write x equals, and it's whatever this number is here. So x equals 0, and we are done. I think I want to look at one more problem, and then I'll save the other ones for you. So looking at problem number 5 over here, we are being asked to graph each of the parabolas and to identify each of those parabola features. I still have it. Let's see. I don't think so. So I'm going to grab this because, again, wherever you see skinny, fat, vertical shift, I want you to just come cross it out because we're not going to be doing that today. We'll focus on that tomorrow. So looking at this first one here, we can see our graph right away. Like I said, if you're missing any values at this point, your job should be to plug them in. So we're going to put a 1 right there just to hold that spot. Now, we're asked about concavity. Since our a value is positive again, we know our graph will be concave up. Over here, we see that our c value is 8. That means our y-intercept will be 8, or we often say it as 0, 8. Great. Now, we should be finding our vertex and our line of symmetry before we go through and do any of these points over here. So, in order to do that, we're going to do that -b/2a formula. Our b value in this problem is a -9, so it's going to be a -9, which of course will turn into a +9, over 2 times 1. So we're going to have a positive 9 over 2, which is 4.5. Now, we haven't gotten a decimal for one of these in a while, but that's okay. Remember, the way this works is you want to take whatever the value that comes from that formula and put that smack dab in the middle of our graph. Since that is our x value here, we know that that's going to give us a point over here, or the x coordinate of that point will be 4.5. Now, to get the y coordinate, what you're going to want to do is plug in. So I'm going to come over here, I'm going to take my original function, so 1, and then I'm going to put 4.5 wherever I see an x. So I'm going to have 1, 4.5, negative 9 times 4.5 plus 8. And again, this is where your calculator is your best friend. Use your calculator to do that lifting. So 1 times 4.5 to the second power minus 9 times 4.5. And then we want to say plus 8 at the end. And we get a negative 12.25. So that's going to be the value that goes over here, 12.25. Now that is a point. Now we have been used to like looking at nice points, but the truth of the matter is we don't always get those. A couple things to realize though, this is our vertex. So we can actually come over here and write that vertex at 4.5 and then negative 12.25. That is the vertex we just found. And of course, once we know the vertex, then we can write our line of symmetry, which will be x equals 4.5. So we've done a lot of work at this point. We've identified a lot of those features. We can kind of start to see a graph of this thing, but we should get more points. Now, the way you get those points, you can vary it a little bit, but for the most part, what I tell my students to do is I say to go backwards and to go forwards. So if we came over here, we're at 4.5. Let's just see what happens at 4 and what happens at 5. We kind of work our way around where we're starting. And then I'll go up to 3 and I'll go up to 6 just so I can get a picture as to what is going on. So again, the way we do this now is we just plug in those values. So I'm going to have 1 times 3 squared minus 9 times 3 plus 8. We're just plugging those into the original function. And then similarly, I'm going to just copy this for a second. Copy, paste. And then now, in each of these problems, I'm not going to be plugging in 3. I only needed to do that in the top one. This one I'll plug in 4. This one I'll plug in 5. And this one I'll plug in 6. Now, if you're questioning where did these values come from, I just picked a nice number that came before 4.5. And then a nice number that came after 4.5, so that was where I got 4 and 5, and then I just kind of went in nice increments close to there. So at this point, let's let our calculator do the work. So we'll have our parenthesis, or our 1, parenthesis 3 to the second power minus 9 times 3 plus 8. When you hit enter, we get negative 10 that comes out. Now remember, we're just typing that again, but we're changing the number in the parentheses. So now we're going to change these to both 4s. Then I get a negative 12. Then I'm going to change them to both 5s. I get a negative 12 again. And then I'm going to change it to a 6. And I get a negative 10. Now remember, these are ordered pairs, so this is 3, negative 10, this is 4, negative 12, this is going to be 5, negative 12, and then 6, negative 10. At this point, we definitely are very close to being able to graph it. The only piece we haven't identified is just our x-intercepts, which are located down here. Remember, to find your x-intercepts, we get a little bit more detail. It says find the x-intercepts by factoring. So we want to grab our original equation, x squared minus 9x plus 8, 1x squared minus 9x plus 8. And if I want to solve this by factoring, I need to factor it. So let's grab our x. Remember to factor this. 1 times 8 gives us the top. That's 8. Negative 9 goes on the bottom. This will be 1x over 1x over. We're looking for two numbers that multiply to give us a positive 8. that add to give us a negative 9. Hopefully you can come up with the negative 8 and negative 1. Those would multiply to be a positive 8, and they would add to give you a negative 9. So my factor will be 1x minus 8, or just x minus 8. And my other factor will be 1x minus 1, or just x minus 1. And of course, since we're trying to solve this, we set this equal to 0, which means this is set equal to 0. Now at this point, we want to use our zero product property. So we want to take this factor, x minus 8, and set it equal to 0. And we want to take this factor and set it equal to 0. To solve this, we would add 8 and add 8. We get x equals 8. On the other one, we're going to add 1 and add 1, and we'll get x equals a positive 1. So these are our roots, also known as our solutions, so or even our x-intercepts. So remember, these get written as 8, 0 and 1, 0, 8, 0, 1, 0. And now let's just graph all of these points. We kind of have a list of them here. So starting at our vertex, negative 4, or 4.5, negative 12. So 4.5 would maybe be like somewhere right around here. And then that'd be negative 12 1/4 would put us all the way down just a little bit below there. So that would be our vertex. Other points that we know, at negative 4, we were at negative 12. So that would put us at a spot exactly right there. At negative 5, we were at negative 12. Now you got to be careful with the scale. Negative 5 would be in between 4 and 6, so that would put us kind of right in the middle there. So we've graphed these two. At negative 3, or I'm sorry, at a positive 3, we were at negative 10. Positive 3, negative 10. At 6, we are at negative 10. So we're getting all of those values. Now for our roots, right, we do have those roots listed down here. We know we're going to hit the point 8, 0 and 1, 0. So 8, 0 would be right here. 1, 0 would be right there. What else do we got? Oh, our y-intercept. That's good to see too, right? So we do have another point over here, 0, 8. That would be our y-intercept up there. So we can kind of start to see this thing come through. So let's just connect the dots now. Got pretty close to that one. Try to hit your dots better than I did. Let's try that one more time. We'll call that good enough for now, but that is our parabola, right? So you got 2 more of these things to graph. As you can see here, there's a lot of information coming together. So it's okay to practice. It's okay to sit there and question, why are we doing this the way we are? But please ask any questions that you guys do have. Thank you so much for watching. Complete those and submit them for homework. Have a nice day.